Morning, everybody. Thank you for coming and welcome to the second Saturday Science event of this spring semester. We have two more coming, so please be in tune. And today we are lucky enough, fortunate, in fact, having Dr. Boyajian, Tabi, the way we call her. She's an associate professor at the Physics and Astronomy Department of LSU. She got her PhD from Georgia State, and then she was a Hubble Fellow also at Georgia State after that. And then she went to Yale, and then she came to LSU already a few years ago. And she's an astronomer, and she's famous for many different things. One of them is because she named a very popular and curious star in the sky called Tabi's star. You can Google it and see the story, which is pretty fascinating. But today she's not going to talk about Tabi's star, maybe a little bit, I don't know. That's mostly about Eclipse. So, Tabi, all yours.
Thank you. All right, first off, can anyone not hear me? Anybody not hear me? I can use the microphone. Okay, great. All right, so thank you for the introduction. So to get started, I'm going to be talking about eclipses mainly. I will kind of touch on my star a little bit because it does share the same theme. But just to give you like a little introduction about what eclipses are, as viewed from Earth, here you have the Sun, Earth, Moon system, right? And so the Earth spins around once a day, the Moon goes around the Earth once a month. And as it goes around the Sun, right, you have these alignments where you have the Sun, the Moon, and the Earth, and then you have the Sun, the Earth, and the Moon lined up. So at each of these locations, right, you have one body passing in front of another body, and that casts a shadow as we see here on Earth. Now, the two flavors of eclipses that we have here, the first one is lunar eclipses. It would be poor form not to mention this, but this talk is mainly about solar eclipses because there's something big happening in a couple weeks. But anyway, so for completeness, lunar eclipses happen when you have a full moon, so the moon is in full phase, and you have the Sun, the Earth, and the Moon in that configuration. And what happens is the Earth casts its shadow up on the Moon. Now, because the Earth is so large in this configuration, you can see that its shadow is quite big, and pretty much it covers the entire Moon. And so basically, if it's daytime, meaning you're opposite of the Sun and you can see through that shadow, then you will see a lunar eclipse. So there are three different flavors of lunar eclipses, and that depends on what part of the shadow that you're going through that the Earth is casting. So the first one is the penumbral eclipse, and the second two are a partial eclipse and a total lunar eclipse. Now you can see there's an eclipse sequence at the top of this slide showing both the partial, and then once you get to that very center point, the moon turns this kind of like dark reddish color. So this is in fact a full lunar eclipse, not when the moon goes away. It's actually like, well, the moon never goes away. That's a good thing. But what happens is that it's completely behind Earth's shadow, and the sun's light is coming through the atmosphere, refracting, and that's why you have that kind of red glow as that sunlight hits the moon. And then it goes through its partial eclipse phase, and you can see the moon is full again. So the next lunar eclipse is on Monday. So you can wake up around midnight and view the lunar eclipse. It is I think the least spectacular of these eclipses. It's just called the penumbral eclipse over here on the far left. So the moon is going through the very darkest part of Earth's shadow, but it'll kind of look like a cloud is kind of like passing over the moon. Eclipses typically come in pairs, as I'll get to in a minute. So the lunar eclipse, and then there's a solar eclipse. So a solar eclipse happens at the opposite configuration where you have the Sun, and then you have the Moon, and then the Earth. And so in this configuration, that's where we call it the new moon phase. And I like this diagram here because it actually shows the kind of scale that we're looking at to view a solar eclipse and how tiny it is. Recall that, right, just go backwards. Okay. On this slide, right, the Earth shadow is very big that it's casting. And basically, like, you know, it covers up the entire moon. On the other hand, the moon is pretty small, so the shadow that it casts is not very big. So these are actually very, very special to view from the surface of Earth. You have to be in a very specific location. So there are 3 different types of solar eclipses. There's a partial eclipse, an annular eclipse, and a total eclipse. Now the difference between the annular eclipse and the total eclipse comes from how the moon orbits Earth. So if you think of the moon orbiting around Earth, it's not perfectly circular, it's kind of like egg-shaped. And so sometimes it's a little bit closer to us, and sometimes it's a little further away. When things are closer to you, they look apparently bigger than if they were further away. And so the annular eclipse happens when everything lines up and the moon is just a little bit further away, so it can't block out that entire disk of the sun. But a total eclipse happens when the moon is a little bit closer to us, and so it is able to block out the entire disk of the sun. Okay, so important note. The next solar eclipse is on April 8th. This is not this Monday, but 2 Mondays from now, and this is a total solar eclipse. Now, total eclipses are pretty special, and I want to try and trace out the geometry, what needs to happen for you. So first we need to talk about sizes, right? So the size of the Earth. Astronomers like to build scale models of things, and talk about really, really big things, really, really small things. So let's try and put it in perspective and shrink Earth all the way down to the size of a basketball. And in this scale, the moon will be the size of a baseball, right? So something I can hold in my hand is something I use your hands to hold. Just me, you know, but anyway. Okay, on this scale size, how big do you think the sun needs to be? Anybody? How big would the sun need to be? Yes?
Size of Jupiter, maybe?
Nope. Smaller? That's perfect. A house. Wow, you must have peed. No, I'm just kidding. All right, so the sun needs to be about as big as a house. That was good, right? Okay, so how do you get something as small as the moon to cover up something as big as the house? Remember, we are Earth, right? And the moon is going to cast a shadow, or it's going to block out the sun as viewed here from Earth. So that's the other thing we need to think about here. So we got size, and then we have distances. So here, if I have the basketball and it's sitting here on this desk, right? The moon on this size scale would be about, I don't know, say that back row of people in this room. Okay, anyone want to take a guess of where we got to put the sun to have this all work out? Anybody? Okay, who says Alabama? No. Okay. Who says Antarctica? Also not it. Okay, about downtown. Right, so I think it's like 3 miles away or so. Like this is gonna be pretty far away, right? So like this kind of like helps us kind of understand how like the size and the distance plays into things. And in the end, you have the size of the moon in our sky as viewed from Earth, and the size of the sun. Even though they're so different in sizes, they're also so different in distances. They're actually the same size in the sky, enough to where that tiny change in the moon's orbit around us can have those 2 annular and total eclipses, which is kind of neat. Okay, so the next thing you may be wondering, you're like, okay, well, the moon goes around the Earth once a month. Why don't we get eclipses every month? It seems like you should be able to. And the reason for this is you have the Earth, and it's going around the sun, and then you have the moon's orbit around the Earth. Now you need to have all these 3 things in line, and that doesn't happen because or it doesn't happen often because the moon's orbit is tilted by like 5 degrees, which doesn't sound like much, but it's enough to make this not happen. So that you don't have the moon's shadow being cast on the Earth each of these months. Let me put it over time so I can kind of point this out. And so each time the moon orbits the Earth, right, you're looking at where the shadow is being cast, and sometimes a little bit too high, and sometimes it's a little bit too low. And here you can see it's crossing up. There you go. And as the Earth-Moon system is revolving around the sun, you do get this perfect alignment about twice a year. And so you have potentially up to 5 eclipses per year, just because of the way things move and they cause events and all that. Okay, so this diagram over here to the left hand, sorry, what was that? That's left, yes. The cartoon over there to the left, shows what happens when the alignment is just right for a solar eclipse. This video that's shown on the right is showing kind of what is happening and how you see the Earth's shadow being cast on Earth. Now this black dot right here is called the path of totality. It's only about 100 miles wide, and it's sweeping across the United States, which is shown here, at about 1,000 miles per hour. This path of totality is the only place that is cast on the planet that you can see the entire sun blocked out by the moon. So I'm going to show you this video here, and I'll play it twice, because I'm going to say a few things with it. First is, this is not for the eclipse that's happening in 2 weeks. This is for the eclipse that happened in 2017. So I don't mean to confuse you by that, but I like how this video adds to this animation of that path of totality, that black dot streaming across the United States, but it's also showing what the sun would look like for an observer at each one of these times during the eclipse. And I want you to notice that, I'll play it again, as this dot traverses over the United States, pretty much everywhere, this is true for the eclipse happening in 2 weeks, pretty much everywhere we'll be able to see a partial eclipse. But only in that special path, this path of totality, where you have the exact conditions right for the moon to completely block out the sun, and you will have a total eclipse visible. So your viewing location is very, very important if you want to get the full coolness out of what you're viewing for the total eclipse. Okay, so viewing location matters. I do understand that a lot of people cannot go to what's called this path of totality, but I do urge you to go at least at some point, and I'll try and convince you, and then give you your other options, and towards the end of the talk. So this showed up on Reddit a couple days ago. I thought it was pretty cute, right? This stripe right here is where you want to go to see all of the coolness that the total eclipse has to offer. All right, so who is lucky? All right, we have about 31. Did you have a question?
Oh no, we're going.
Oh.
That's all. I thought you were going to ask who's going.
Okay, who's going? So I have told my students in the past and now that I will write them a doctor's note to, get out of work or school or whatever. I'm probably not the right kind of doctor. But if, your teachers or whatever don't care, yes, come to me, I'll write you a doctor's excuse for that. I'm not going to say that they're going to take it. So going on this. Oh, who saw the eclipse? Who traveled to the path of totality in 2017? Okay, a few of us? Sorry, I did. Where did you see it?
In Tennessee?
Mm-hmm.
Yeah.
Mm-hmm. I went to Nebraska. I took my kids there too, it's great. And they think Nebraska is the coolest place ever now. And I'm like, you guys are probably the only, they're really low at the time. You guys are probably the only people who've ever said this about Nebraska. No offense if you're from Nebraska. It was a wonderful time. But I don't think I've ever heard anybody say that. Okay, so for this next eclipse, there are about 31 million Americans, and I apologize if this is very U.S.-centric. The eclipse does go through Mexico and Canada, but whoever made these studies just disregarded of that. Anyway. Okay, so there are about 31 million Americans that live in that path of totality, that special strip where the moon shadow will completely cover up the disk of the sun, right? And it will literally get dark in the daytime and you will be able to see the stars. If you kind of expand yourself out, there are, several 100 million people within like a thousand miles distance, so kind of driving distance to go to the eclipse. And this right figure over here kind of breaks it up by state. I think it's quite cute that Tennessee has 80 people in that path of totality. Well, probably because it's a very rural area, and two, it's just a little sliver of Tennessee that it's actually kind of cutting off. Okay. The rest of us have to travel there. So what this graph shows is the kind of likely routes that each person from every state, taking into account the populations and the road maps, getting to that path of totality, and how many people are going to be traveling around those routes and where they're kind of going to end up. It's been, or kind of every like hotel and campsite and things like that, they've been booked for a long time. So if you haven't made plans yet, right, call a friend, because I don't think you can really get into any hotel or anything like that. Any kind of planetarium or museum or school or kind of anything, there's going to be huge events up and down this entire strip entirely. Like there's even events that are happening like here in Baton Rouge where we only have about 80% coverage. So this is a day where you can kind of go out and interact with astronomers, citizen scientists, and things like that, to view the eclipse, with special equipment and things like that. But you actually don't need anything special. I'm getting ahead of myself. Anyway, so the last point here is, I think worth mentioning, is that so the eclipse happens on a Monday. So everyone's going to kind of probably take a long weekend. People are going to be trickling in, and it'll be fine getting there. But just like the one in 2017, which I've traveled to, that I was in a very rural part of the country anyway, but the locals were taking pictures of the traffic, and this was like a one stop sign town, not even a one light town. Anyway, yes, the traffic is going to be gridlocked right afterwards. Like that's like everybody leaving all at the same time. And so they're expecting somewhere around 4 million people to travel to the path of totality. So just keep that in mind if you think you're going to be getting back home that night. That's probably not the case. Yeah, so I canceled my class on Tuesday. That's the case. Okay, once you get there, there is, you've overcome all these obstacles. You have a place to stay, you got yourself there. You have one last thing to worry about. When you're doing any kind of astronomy or observations, you have to worry about the weather. So if it's cloudy, you won't be able to see the eclipse because you can't see the sun, right? You'll be able to see some of the effects that I'll talk about here in a minute, but it's definitely not going to be awesome, guys. And that's just like, you can't really say what's going to happen. And so what I'm showing here are two different things. The one here, the big chart on the left, is a compilation of the last 30 years of cloud coverage data from the National Weather Service. And it's showing the average of this 30 years, showing that as you go down here to the southwest portion of the United States, in that eclipse path, statistically, the weather is supposed to be a lot better, meaning have more sunny days than cloudy days during that month. The chart up there on the top left shows what the weather conditions were like on that day at that time when the eclipse happened 1 year ago. And so this doesn't show the same thing as this because it's just like, it's just one snapshot for one day. And so there you have, it's sunny up in Maine and Montreal, where here it's just like, we don't think it's going to be very good viewing conditions at all. And so it really is a gamble on where you choose to go based on weather conditions. It's more likely that you're going to have a better chance of viewing the eclipse from, say, the Texas, Arkansas region that could be totally host. We just don't know. And so there's a couple of websites that I listed here that are actively tracking what this weather patterns are going to be and viewing conditions and so on. Okay, so just to recap, this eclipse is going to be totally awesome for several reasons. First, this path to totality is going through Mexico, the entire United States, up from Texas to Maine, and then up through Canada. The amount of time that the moon will be completely blocking the sun in this path of totality depends on where in that path you are. So that stripe, if you're close to the edge, it'll only be a few seconds of when it's being completely blocked. But if you're closer to the center line there, the maximum duration of this eclipse is about 4.5 minutes. So you want to get as close to that center line as you can for the best viewing. A partial eclipse again will be visible for pretty much the entire country. Again, if it's not cloudy. At convenient times of the day, and I say this to remind myself that if there's any educators in here that have schoolroom for the kids, or maybe you're a manager somewhere, right? And it's 1:30 in the afternoon on a Monday, and you can take all your kids outside to go look through a pinhole camera or something cool like that. You should do it. So please go do that. It's pretty awesome the kind of things you see and do. But I am going to talk about safety here in a minute. The kind of things you see and feel. So the temperature is going to drop amazingly, and the nature is actually going to respond to what's happening. Very much unlike a cloud going across the sun. It's like the sun is actually being blocked out. And then lastly, you will see the stars and planets in the daytime, guys. It's so super weird. And you won't need a telescope. It's pretty awesome. Okay, let's look at, safety first. So I have some Eclipse glasses here. There are Eclipse glasses in the back of the room. They are free. Please take some for you and for your family to view the eclipse, right? You'll need this wherever you go. Okay, good. Yes, they're not very fashionable, but you really need to use these guys. Please do not look at the sun ever with your eyes, or even just sunglasses. These are very special sunglasses. They're not very fashion forward, but they work really well. They will. So I actually learned a funny story. I'm getting sidetracked, but I think this is worth sharing. So Newton, Sir Isaac Newton, the one who invented gravity, or discovered gravity, right? He was a very, very smart guy. He actually did experiments with looking at the sun, trying to figure stuff out, what he could see. So he actually purposely looked at the sun, and he burned his eyes so bad that he couldn't see for several months. His eyes ended up healing, thank goodness. But if you think about, you ever go out or you ever see somebody take a magnifying glass and kind of start fires with it, right? You don't want that to happen to your eyeball. Please don't do that. Okay. Anyway, so take your Eclipse glasses with you to the path of totality. Take some for people who forgot them. All right. You, as the eclipse is happening, right? Put your Eclipse glasses on. Go look over the sun. It's still partial eclipse, right? Not until it is 100% covered, right? Can you take your Eclipse glasses off? So that path of totality is strictly the only place where you can take your Eclipse glasses off. If you're 99.9% to the path of totality, but you're not quite there, you cannot take them off. The sun is that bright, even if it's peeking through, it will burn your retina, and you do not want to have doctor's bills for that. Plus, they can't really fix it if it's really, really damaged. So when you are in totality, you can take your glasses off, view all the amazingness, and then once the totality is over with, put your glasses back on. Okay. And last piece of advice for viewing things, unless you know what you're doing, this is your job, you know what you're doing, please don't try and take any pictures during the eclipse, right? It's dangerous, because a lot of people try and take it with equipment that is not really made for taking pictures for the eclipse. And this is something that only lasts for a couple of minutes, and there's a lot to see, and if you're like fiddling with like battery packs and like filters and things like that, it'll just take away from the whole experience. There's people whose jobs it is to take pictures like this, just take one of those that you find from the internet, take it as your own, and be like, I saw this, right? You don't need your own picture. It totally takes away from the whole. Okay, what will you see? So, the eclipse sequence goes is this. So the moon is starting to cover the sun. This happens slowly. This process takes a couple of hours. Right before the sun disappears, you have two things to look for. The first one's called the diamond ring. So the diamond ring shown over here to the left. This is about 10 to 15 seconds before totality. And this is where you're seeing the last kind of like bit of the sun kind of peek over the moon's edge. It looks like a diamond ring. The second one is called Bailey's beads, and this is about 5 seconds before totality. And here you kind of just see these like girly bright spots kind of go around the limb of the moon. And this is from scattered sunlight going off of the craters and mountains and moons. They're kind of like peeking through. Okay. Then you have what's called totality. And this is where you only see it when you're in that path of totality. And two main things that you can look for here with respect to the sun, that is, the first is the solar corona. So the sun is a very bright thing. It's the brightest thing in our sky. And it's actually so bright, we actually can't see as astronomers, we can't see its diffuse atmosphere that's around it because it's so bright. And the moon ends up being a perfect little like thumb that you can put over a bright thing and see all this faint stuff around it. So it's actually like a very unique and special time for astronomers to study this diffuse atmosphere and about it. And it kind of looks like this hairy kind of like, stringer thing sticking out from it. Also on the limb of the sun, you can see the chromosphere here at the bottom right, where this is where you're seeing kind of like the surface of the sun, but what's associated with that is these kind of solar storms that you can see popping up from the limb here, right? These solar storms, I mean, they look tiny, but they're actually quite big. They're several times the size of our own Earth, right? And they're caused by these huge magnetic storms around the sun's surface, and they're associated also with these forgetting the word. Anyway, when the sun erupts and coronal mass ejections, when they spew all this like high energy material and particles like in our direction and can interact with Earth in cool ways and in not very cool ways. So one of the parts of effects that we get are the aurora borealis, or the northern lights. Happens in the southern hemisphere too. But if they're very, very, very strong, then we get things similar to the Carrington event, if you're familiar with that, but it can cause like severe electrical storms here on Earth, like pretty much like wiping out power grids extensively. And so like this is a big interest to astronomers. We want to study this. We want to be able to predict it and mitigate the effects that it has here for Earthlings. Okay, and so the last of this eclipse sequence is basically the opposite of coming in, so you have kind of the moon slowly uncovering of the sun. Okay, so a couple of things to look for. The first one is the pinhole effect. So this was actually the eclipse taken here on or at the quad down at LSU on October 14th. There was an annular eclipse. We were not in the path of annularity. I don't know if that's a thing. We were not in the path of annularness. Regardless, we still got to see this partial eclipse, which was like, I think it was nearly 85% from here in Baton Rouge. When the sun was 85% covered by the moon, you couldn't tell if you didn't know what was going on. It was that crazy. But if you looked at your surroundings, this pinhole effect was happening. So the leaves on the trees are making like effectively a pinhole camera. And so all of the light that was shining through these leaves would cast like tiny images of what the sun looks like. And so you can see this kind of behind here. That's my kid right there. But you can see all the little tiny suns there projected for the moon. totality is this 360-degree sunset. So essentially what it is a wide field camera showing, did that movie play? I'm going to play it again, if I can. Okay, that's a fisheye lens kind of showing the same thing here. But essentially what you're seeing, you have like, the sun being eclipsed, and so the entire sky is dark. You have the corona that you can see kind of like this hairy mess around the eclipse that's happening, and then you see the stars and everything in the sky. But everywhere around you on your horizon is this like bright, it's like a sunset, but it's everywhere. You know how sunset is typically is to the west, right? It's very, very cool looking and very surreal. Okay, if you are going and you're kind of a sciencey, nerdy type person, there are things that you can contribute in that you don't need any like, sophisticated equipment or anything like that. So these are citizen science projects. I'm naming a few here. So I did mention a couple of slides ago how the temperature will drop in nature response. So when you're in this path of totality and the sun is completely covered up, the temperature will drop about 20 degrees. It is weird and it is cool. And then nature around you, like the birds are like the weirdest things. Like, they all like think it's nighttime. And so they'll do their nighttime routines, they'll go to roost and they'll sing their songs. It's really kind of crazy and cool. Here it shows an image of some of those flowers that are open and closed in the daytime, nighttime. They don't do that with clouds, they do that with the eclipse. And so there's various things that you can do that people are help tracking how nature responds, just depending on where you are and what is surrounding you. There's some other citizen science projects. This one that are here involves making, this was for the 2017 eclipse, they're doing it again, making an eclipse mega movie. So here you can see there's about 1,000 people that submitted their images during totality, and you can see that little red dot there that corresponds to the image that's being shown up there. So you can see that is a few hours duration of what the corona is doing during this amount of time, which is crazy cool. I'm just thinking like, wow, that was a lot of work stitching all those images together from all these people with all these different setups. Anyway, there are many citizen science projects that are available out there. I can give you a link if you're interested, and I can send it to you. Okay. So, I'm trying to convince you that's special. You need to go to this path of totality. How special is this path of totality? So this was a study that came out a little bit ago, and what they did is there's an animation over there to the top right, and this is a heat map over here on the top left, and what the animation is showing poorly in this lighting, I think it's going. Is it going? Okay. Is where the path of totality traces out for the past 5,000 years. And what they're looking at is, is there a place on Earth that never gets to see a total eclipse? Like, is there a spot on Earth that gets more total eclipses than other? Is there something unique that, comes out of the study? And what they found was things that we kind of expected. The first is there's more eclipses in the northern hemisphere than the southern hemisphere. And that's just because of this kind of weird tilt that the Earth has in its orbit. The second one is that there's more eclipses in the summertime than in the wintertime, and that is purely because in the summertime, this counts as summer in the northern and southern hemisphere, because the sun is up for longer, so you have more of a chance to have a solar eclipse. And the last thing they found out was that, there's about, for any given location on the map of the world, there's about 360 years between total solar eclipses viewed from that location. And that's kind of cool if you think about the eclipse that is happening in a couple weeks. If you look back to the eclipse, the total eclipse that happened in 2017, they crossed paths right in the middle here in Carbondale, Indiana? Illinois? Sorry, I get those two mixed up. So this is like really cool because it's telling us, okay, well, this eclipse, for that one point in time, this eclipse is coming like hundreds of years early, right? Because it's supposed to, for any one point on the map, come, every 360 years. But here you have, 7 years apart. So that's kind of cool. Yeah. All right, so looking into the future, I do encourage you to try and go see the eclipse in 2 weeks. Only about 1 in 10,000 people on the planet are able to see a total eclipse in their lifetime. If you aren't able to see the eclipse in a couple weeks, hey, you have an excuse to travel now. The next total eclipse goes through Iceland and Spain, and that is in 2026. So I can highly recommend Barcelona. It's a really fun place to go. Haven't been to Iceland, but I hear it's kind of erupting right now, so I don't know. But it is a beautiful place. So the next total eclipse in North America is in 2045, and then following that, the next one is in 2078. But Baton Rouge gets to be in the path of totality. That's pretty cool. Yeah. All right, so go in 2 weeks, because that's like, okay, I just wanted to give a little historical perspective of what eclipses were like, kind of for like ancient civilizations and what they thought, because it really is a powerful thing to experience. And so here are a few selections. I'm not a historian, this is not my bag, but this is kind of what I learned from going on a deep dive on the internet this past week. Just bear with me, try not to ask any hard questions. Okay, so in ancient China, their explanation for an eclipse is you have this dragon Z and it's attempting to eat the sun, basically. And so what happens when there is an eclipse of the sun goes away. So like people try and scare this dragon away, they shoot arrows at the sky, and they bang drums really loudly to try and scare it away. So that's their deal. In Norse mythology, you have two wolves, the story of these two wolves, and they're, each one is chasing the sun and the moon around in the sky. Well, at some point, Skull catches up with the sun, and by doing this, it causes the sun to disappear temporarily. So what do people do to fix this? Because you want the sun to come back, right? And so they also make a bunch of noise, and they have like all these rituals and stuff that they perform to get the sun back. And if they're successful, the sun always comes back. That's good. Okay, so a couple other stories. There's in Hindu mythology, there is a demon named Rahu, and he was said to swallow the sun during a solar eclipse. And according to legend, Lord Vishnu did not like that, so he decapitated Rahu, and because he decapitated him, of course the demon is dead, but his head is still alive. And his head is the one that periodically comes over and makes the sun get eclipsed and go away for a little bit. So during eclipse time, they perform rituals so to protect themselves from any sort of influence from this demon that is actually taking back over the sky. Immortal demon, but only his head is immortal. Okay. Lastly, the Mayan civilization. What they believe is like when the sun goes in the sky, when it's dark, it turns into a jaguar, and so it's able to defend itself in the underworld. And if there's a solar eclipse, this jaguar is coming out way too early, and they don't like that. They don't want the underworld heat up during the daytime. And so again, they start lighting fires and beating lots of drums to try and get this jaguar to go away for the sun to reappear again. So these were some select stories that I picked out. There are lots of so the Aztecs, for instance, they actually believed that they didn't impose any sort of deities or stories or anything like that to explain eclipses. They thought it was interesting. They actually thought it was a purely astronomical event. This is a thing that happened, and then we carry on. So I think it's cool how, like, you know, there's a theme here between all these places around the world and how we explain it. But, you know, it wasn't needed per se. Anyway, I might be going a little time. What time are we supposed to end? Like in 1 minute?
Whenever you want.
Okay, I won't keep us too long. I may kind of skip ahead on things.
You have
But,
time.
okay. Well, I will try and respect your time. So, lunar eclipses, solar eclipses, we know what those are. You will never ever have the sun in between the earth and the moon. This would not be good. So when going and looking at things other than a lunar and solar eclipse, you will either need a spaceship or you will need a telescope. So this is an example of, we have these little robots on Mars, and they're like roving around. And this is from the Perseverance robot, and it ends up that Mars is 2 moons, Phobos and Deimos. Eclipse, Phobos eclipse is the sun twice a day. This moon is very small and dinky, even though it's pretty close to us. And so this is not what we call total eclipse ever. It is an annular eclipse. But you get to see them twice a day if you're on the surface of Mars, which is pretty neat. Let me see, if you have a telescope, the planets in our solar system, Venus and Mercury, were transiting back 20, 30 years ago around their sun. These are images of them. I think it's kind of cool because it actually shows how small a planet is with respect to stuff. It sounds really big, guys. It's very, very big. And then looking outside of our solar system, in 1995, which is nearly 30 years ago, we caught a glimpse of like the first planet outside of our own solar system, and this actually put like humanity in like a frenzy because we were like, well, you know, like we thought we were special, we were like the only ones out there, but now we know other stars have planets. We thought our star was the only special one to have like 8 or 9 or however many planets that you call around it, and that's where Earth is and people are. And now we know there are planets around other stars. That brings us one step closer to, you know, answering that question, like, are we alone? Is there anybody out there? And so this whole idea of eclipses kind of continues on through this theme in what's called transiting astronomy or transiting exoplanets. So the method over here is described by a sun, and you have a planet that's perfectly aligned in your line of sight, where periodically it'll come around and cross against the limit of the sun and block out a little of that sun's light. We've now been able to build telescopes and instruments sensitive enough to detect this and to do really boring missions like point and stare at, you know, hundreds of thousands of stars and watch for this to happen. And when I say sensitive enough, it is similar to having the entire Empire State Building lit up with lights, like entire thing lit up, and then you have one person in one of the windows take one of the blinds and they drop it 1/4 of an inch. That's how much light decrement our instruments are able to detect. Really good for a bunch of stars. And this here shows a image showing showing for each one of these dots, the planet transiting its stars, so coming locking in front of its light. And the color shows how close that planet is to the stars, basically how hot it is. The size of the circle says, okay, well, that's how big that planet is. And how frequent it is, saying, okay, well, that's how frequently it is orbiting its host star. And that little footprint right there, that kind of big cross, it's only about as big as your fist held at arm's length in the sky. So that's how many transiting planets you see in a little portion of the sky like that. It's kind of cool, right? Okay, one more thing I think is really wow when we talk about this is taking the same kind of data of these transiting exoplanet systems and looking at the ones that all host multiple planets that transit. And so what this shows is our solar system, you can't see the white line, but trust me, where it says solar system, that's our sun. And then there's like kind of concentric circles going out, showing where the planets in our solar system are. This isn't going like past the orbit of Earth, I think. And these are all the systems that we've detected in multiple planet systems that are transiting. And it shows like the diversity of like the worlds that are out there and how compact these systems are. That is just like really, really, really cool. Like we never really expected anything like this, right? And now we have like this, data set here that's hundreds of these systems, and we have over 6,000 or nearly 6,000 exoplanet systems that we've detected today. And I nearly am almost done. So this is, as I promised, my star. Technically it's Boyajian star, but we're not formal. We can just call it Tabby star. Also has its name KIC 8462852. It's a normal looking star, except for the fact that it has these brightness changes, right? These kind of eclipse looking events. And here is kind of a zoom in of what I'm talking about. They're kind of straight, flat line at the top. That means nothing's happening. But when it kind of dips down, that means something's going in front of the star. So it kind of looks like that transit, like a planet going in front of it, but it's weirdly not. It's a lot bigger, it's a lot longer, and it's very, very weird. And so we have 4 years of data on this star, and it is all just like, it all blows our mind. Like astronomers are like, that's bad data. But it's super weird and real, and we're trying to figure out, right, where all this light is going during these times. So like there's 4 different families of scenarios. Last one is like you get bad data. We've kind of proven that wrong. So 3 different families of scenarios. I've spent this time talking about something orbiting something else and kind of getting in the way. It could be something inherent to the star itself. But if we look out in some things in our own solar system, things that we can think of, there's all these different scenarios of what could be blocking the star's light. So you have asteroid belts, you have planets smashing into each other, you have these giant rings or disks of planet formation, all this stuff, even like giant swarms of comets that we've all thought of to try and explain this really complicated data, and I don't have 5 hours to talk about this, or even one. But it's something that like we're still having a hard time explaining all the observations that we have with any single one of these scenarios. So I just think it's kind of cool, like, the kind of things we can learn from eclipses, like close to home and also like really far away about other planets, the diversity of planets and the diversity of solar systems, the kind of mechanisms that are going on within those solar systems. And it really makes this like an exciting field to work in. So I'm going to leave like this. I can take questions. It's just an animation from Celestron, which is a telescope company of the 2017 eclipse. You can see as they're going through this, the different phases, they do have a little bit of cloud cover. You can watch it kind of like flashing this cloud cover, but you can see for most of it there. Anyway, thank you.
Questions?
Question on the length of time you can look at the sun. So I understand you're supposed to not look at it all constantly. You're supposed to, with your glasses, off and on.
Well, I mean, if you have your eclipse glasses, right? I'm not sure if there's a length of time where they say you can't stare at the sun just like this for an hour, but they're made out of paper. They're not very comfortable.
Yeah.
Yeah.
Well,
so
one of the glasses I got back in October said to every 10 minutes,
Yeah, honestly, I don't think you'll be wanting to like just sit there and stare at the sun.
Yeah,
for 10
which I
minutes
saw
because
people at
it's
the
like
observatory doing.
Pac-Man sun, and it's not changing that quickly. Like
Right, exactly.
that whole sequence takes a couple hours. So like you look at it, stay
Right.
a couple minutes, see if you can see anything cool, and then you're like, I'm totally done. I want to do
Well,
something
I
else.
saw people laying on lawn chairs and they were there the whole time.
Huh.
And I told them, I don't think you're supposed to be doing that. Because
Yeah. I
is that
question
bad
that.
for your eyes?
Hopefully they were like napping. Were they able to walk when they got back up?
Yeah, and on welding lenses, 13 is supposed to be okay.
I have that written down. down somewhere, but I don't know,
Yeah.
I'm sure the internet knows, I would just
Yeah,
make sure it's a
well,
reliable
it's
source.
just different people say different things, so.
Okay, yeah, yeah, I would make sure it's a reliable source, we can find it online.
Yeah,
So the Sky and Telescope is a astronomy magazine that's run by, well, it's managed by the Professional Astronomy Society that we have. That would be a reliable source. They publish lots of things. So there's also the Planetary Society. I got a lot of this material from these, the Great American Eclipse.com. There's also nationaleclipse.com. I would consider these both reliable sources. Yeah.
and seeing the flowers open and close in such a short period of time, where do you go to see that on the websites?
You would, well, you would have to be in the path of totality to see that, but there's a citizen science project that tracks all these things. Is that what you're talking about?
Yeah, it was on the, when you.
Yeah, I can show it to you after we're done here. Open it up. Oh, did you take a picture of that QR code?
Oh,
I think
no,
that was it.
I didn't, no, sorry.
Go back.
That's savvy.
Do you have a question?
Question there?
Has any scientist before made planets ever, like, when
Okay, so the question was, have we found a planet like Earth out there? That's kind of like what we're going for. It's the holy grail. Earth is just very hard kind of planet to detect, and so we found planets out there that are Earth size or Earth mass, but these Earth size planets are, say, in 3-day orbits around their host star. And so they're scorching. They're like 2,000 degrees of Earth, right? It's not like everything that we consider Earth to be. Even like an Earth-sized planet that's Earth mass, you know, around a star that's not like our star. We have these stars called red dwarfs out there. Actually, the most numerous stars out there. And is that really the same kind of planet as Earth would be, because it's a different radiation environment and everything like this. And so, I mean, largely I think the answer is no. But that's what we want to find. It's just Earth is very small. It's in a 1-year orbit around our host star. And so to find something like that, you just need a lot of time and a lot of telescopes, and a lot of work needs to be put into finding a really tiny signal and verifying it. And then, you know, the fact that, you know, can you detect oceans? We're just starting to detect atmospheres in these planets. A lot of these planets that we're starting to learn about their atmospheres are all these gas giant planets. And we are learning a lot about haze production and clouds and things in these other worlds. But the kind of atmosphere that Earth has compared to these things is very, very small. You know, you see the picture of Earth in the atmosphere is like this much of it. It's very hard to detect anything like that. So I think our best bet would be, we're getting there, but we have, you know, a couple of big flagship observatories coming up, like the Habitable World Observatory. That's like 20 years away. So you'll get to work on it, like, you know, when you're all grown up. But like right now, finding all those things is pretty difficult. Yep.
We'd like to know where you're going to watch the eclipse.
Where I'm going?
Yes.
Okay. So we are undecided at the moment. Let me go back to it. Well, the whole weather thing, right? Like, I mean, okay, I'm gonna go back to this. And one thing I wanted to point out. Okay, so everybody I know from Louisiana is going to Texas, right? But this map shows that people from Louisiana are going to Arkansas. Like, anybody here going to Arkansas? Oh, you're going to Arkansas. Okay, and I was like, but everybody I know are going to Texas. We have 2 different spots in Texas that we're like, you know, possibly going. And then on the way over here, I was like, why aren't we going to Arkansas? Because that's like closer.
Right.
And we went there last year. There's this crystal mine that we were like, quartz crystal mining. We went there and it was like so cool and fun. We were like, we could go there and dig for crystals and like, like have the eclipse and, I don't know. So, to answer your question, either Texas or Arkansas, but we don't have a place to stay in Arkansas, so that's, I don't know. It's, both of them are kind of far, but they're totally worth going.
Now, the closest from here, would that be in the Tyler region?
I think so. Wait,
North of
Pulls up
Tyler,
this.
east, west of Tyler?
Something that's labeled. You know, Tyler or Arkansas. Yeah, so it's about 6 hours away.
Yeah, well, I
Yeah.
think it was like 5 to Tyler or something,
Mhm,
you know.
mhm. Yeah, it was mainly just considering places where we had
Yeah,
places to
exactly.
stay and go. Yeah.
Well, I was able to find something, I guess about a month ago,
Mhm.
of bed and bath, you know.
Okay, yeah, I mean, it's not completely, but we're waiting till the last minute to, kind of check out where, if it's gonna be like monsoons in Arkansas, we're just gonna, hey, we're going to Texas, and if it's cloudy, it's cloudy, but we know it's not gonna be raining,
Yeah.
or vice versa.
More questions?
Good luck.
I would just add that if you are in Baton Rouge, do step out around 1:30. Because even if it's 80%, it's quite a phenomenon.
Yes.
I was curious as to why it was called Tabby Star. Like, are you really, I know, but are you really watching? Like, is there something? Tell
So
us.
I was involved in the work so I published the findings on the star, and it became quite popular because one of all these ideas that we had to explain the star that it didn't put up there was that possibly there was some giant alien megastructure that was built and it's kind of swirling around the star and causing all these weird shapes and stuff with this brightness, light output. And so the star became it went viral, became quite popular, and a friend of mine was talking to a journalist, and he said, we were friends, and he didn't want to say KSC or 62852, because it's not really easy to say, he just said Tabby Star, and that went into print, and it just kind of caught on. And yeah, so that's how it came to be. And it's even in our astronomical catalogs too now, which is kind of crazy and
As
weird.
Tabby Star?
Well, it's under Boyajian star, because even though it came up as Tabby star, it was noted, I don't know, a few months after that, it's a sexist thing, because all the things are named after people, they're all men, and it's always their last name. And so this being the first, and only star being named after a woman, and if you're named after her first name, that's kind of sexist. While I don't entirely, I don't think my last name is easy to say, and I'm not very formal, so I'm Tabby Star is fine, but it should be, the formal thing should be Boyajian Star, we can call it Tabby Star, I don't care.
But that's your last name, the B word?
Boyajian, yeah.
Oh, cool.
Mhm. Yeah. Yes.
So why is it not possible to see the corona of the sun during a sunset?
To see the what of the sun?
The corona, the thing that you're seeing outside the moon.
Oh, because as the sun is below the horizon? Oh, because of the atmosphere, during a sunset, you're looking through so much atmosphere, take that sphere and you cut it like this instead of looking up like that. It's too much atmosphere and the light's being scattered, so you can't get that kind of detection.
Just regarding what she asked, and one more question. What fraction of the planets that have been discovered orbit around more than one star?
Oh, okay.
Multiple stars.
Yeah, Tatooine, Star Wars?
Yeah, binary star system.
Yeah, I think there's somewhere around, there's a dozen of them. The Tatooines, you see Luke Skywalker, and there's 2 suns in his sky. I think there's a dozen of those systems. And then, you also have the systems, that's a type S, I don't know, there are these labels to them. And then you also have, so that that would be 2 stars and a planet going around those 2 stars like that. And then you also have systems where you have a star and a planet going around like that, and then you have another star going around like that. Yeah, that's a P type, S or P, I think. Anyway, that's another type of system. And we've actually caught planets, discovered planets in quintuple systems before, and so there was like your Tatooine system, so you have 2 stars in the center, and you have a planet going around here, and then you have another double star system, and they're also eclipsing, by the way, and they're like here, and they're going around this whole system, and then you have another star going around this, which is kind of cool.
So is there a place out there that's more common?
We don't think so. So like people have looked into kind of alignments within like say the galactic disk or something like that, but there's too much kind of evolution dynamics going on within planet formation and the environment that surrounds it to kind of have that sort of ability to trace that back to. So we don't believe that that's influenced by where it is in the galaxy.
One more question?
Yeah, it's not really a question, but if anyone was wondering what Native Americans of the USA think about solar eclipse, we because we talked about Mayas, Hindus, and Chinese, and other people. So we went to Utah, and we talked about solar eclipses to the Navajo people, Inuit people, and they told us that they're scared of solar eclipses, and so their ancestors and themselves, whenever a solar eclipse happens, they actually hide into their houses until the day comes back, and they fast and wait until they fast, don't do anything, don't drink, don't eat until the day comes back.
Yeah, I did read a few things on the Native Americans as well, and there are a lot of myths out there, kind of like widespread, like you will get like cancer if you're out there from the solar rays that do come through the moon or something. Like there's a lot of weird things out there. But you know, viewing an eclipse is not dangerous as long as you have your solar glasses. Please wear your glasses. Never ever look into the sun. Yes.
I thought my daughter just shared, she won't say it, but I thought it was cool. She said Christopher Columbus used that to his advantage because the natives were afraid, so say it because I don't think so. He told them that they didn't give all their food to the colonists because they had to sail back. Well, he was like, well, if you don't give me all your food, I'm gonna make the sun disappear.
No.
And he knew that there was gonna be a solar eclipse.
I've heard that story before. Isn't that amazing?
That's fun.
Yeah. Those
Thank you for
conquerors. It's kind of cheating.
Yes.
Right? You're very lucky. Yes.
Very good. So happy Thanksgiving, happy.
Thank you.
Two announcements. Next Saturday Science is going to be here in the same room at April 20th. So please come. And also there's an event tonight, Nicholson.
Star party or moon party. It's called a moon party tonight.
Can you?
Okay, so there's a moon party at down at LSU at the Landau Observatory, which is the top floor of Nicholson. And there's going to be a bunch of telescopes out there, and you'll be able to see the moon, and I think Jupiter, and a couple of famous binary stars. So Jupiter and Venus for sure. I'm not sure if there's going to be another one. But it's really awesome to look through the telescope. If anybody ever looked through a telescope and seen the moon, you'll believe say like it looks so different and so cool through a telescope. It's totally worth seeing it, even if you're like, I can see it with my eyes. The planets are also spectacular to see.
You ready to go?
No, I will not be there. And it starts at 8:30 tonight at the observatory on campus.
It's open to the public.
Hmm?
It's open to the
Yes,
public.
it's open to the public. Yes.
Very good.
We saw an eclipse of one of the moons of Jupiter on Jupiter there like 2 weeks weeks ago, like 2 months ago, at like the moon party. So we have those kind of things there as well. And I will be there if you want to come over.
Amazing. So you all are invited.